Hey, hello everyone. Thank you for joining today's Tips and Tricks webinar. Today's topic, as you can see, is on threat prevention in hardcore mode. Please use the Q&A chat if you have any questions, and we'll make sure we get to those during the webinar. Today's presenters are Mark DeJura, an SE from Pennsylvania, and Dan Taney, who is the manager of the architects for the East of the United States. Guys, what do you have for us today?
Well, thanks. Dan, why don't you tell them about questions through the presentation?
Yeah, so thanks everyone for joining. And as we go along, usually we save the questions and answers for the end. As we go along, if anybody has any questions about what we're showing, anything that you want us to elaborate on further, I'm going to have all of the Q&A panels up and the chat panel up. So throw your questions in and we'll try to address them as we go, because there's a lot of visual element to this. So it might be helpful to kind of see it visually while we talk about what's being asked.
Sounds good. So Art from the Solutions Architect team presented back a while ago to us, and he had created a threat prevention testing framework which tested some of our capabilities against really recent malware types. And he went through some of these settings, and it was very interesting to me, and I thought it was something that could be useful to everybody. A lot of people will go in and will just set, the optimized profile or click on autonomous, and then we're done. There are a lot of settings you can do to really increase the prevention of your firewalls by manually configuring some of them. We're going to go over to that today. You see our agendas up here, and we're going to go through each of these and let you know how to configure them. So we're going to start off with a warning. All these configuration changes we're going to talk about will impact performance and can impact what files, what types of traffic get passed through the gateway. So please understand what your gateways are doing, what your baseline is. Use some of those great tools that we have for looking at the performance and how it does over the day. And always, before you put in production, you'll want to take a look and test it first, please. So with that said, we're going to touch on autonomous threat prevention just because it's probably very different than what we're going to talk about in configuring everything manually to the maximum settings. So if you don't know, autonomous threat prevention came around in like R8110. It allowed you to do a single click and based on the gateway type, automatically configure that, get the best protections based on Check Point's AI and what's going on currently. It's going to update automatically and provides it. You have to do very little maintenance to maintain it. So just quickly, there are 6 types of deployments for autonomous threat prevention that you choose when you enable that. Just note, all of them have different settings to some degree. Some of those we're going to touch on in the manual configuration. For threat prevention, all of them except the strict are going to do rapid delivery. And also, all of them don't include all the profiles except for strict and monitor. So note that with choosing those. Another recommendation I always make that a lot of people sort of forget about is blocking outbound traffic for protocols that should never connect to the internet. Certainly, here's an example I have in my lab. It includes things like RDP, SMB and CIFS, SQL, NFS, Tor, and VPN. Normally, these are not things that a business or an organization is going to want to connect an internet version of them. Or if there is, it's going to be a very small subset that should be controlled. You also probably want to think about what you allowed to go out to do DNS, and if it's limited to only the hosts that are providing DNS in your network. Also, what types of DNS, now that we have a bunch of encrypted versions that are also on your network. So think about that. And also, this is information we're going to need to understand as we go through this process, a very detailed blocking certain different protocols and file types that are allowed through the gateway. So we're going to start with the global settings for threat prevention. We're going to find that in Smart Console. And on the left, we want to go to the Managing Settings. And then we're going to go to Threat Prevention and click the Advanced button. These are going to set the general parameters for our domain. The first thing is the failure mode. There are two there. You can either fail open or fail close in case of a system error. For the maximum security, we're going to fail in a closed mode. The next point is how we handle classification of traffic. That's done by touching the connecting out to Threat Cloud. We can hold our traffic so that we do the classification before we start inspection of it. You can also block connections if the service is unavailable. Also note, we want to enable the inspection of HTTP protocols on non-standard ports for all prevention blades as well. So moving on to the next setting, we can configure the file types for threat prevention. 8 of them are configured by default, but Check Point actually supports 88 different types that can be emulated. The next setting we want to look at is the size of the files we emulate. By default, that is set to 15 meg. We can set that up to 100 meg, but we recommend something just a little bit lower than 100 meg to make sure the emulation completes. Also, down in the bottom, we see the number of hashes that are stored locally on your gateway. This is the after emulation is done, a hash is created so we don't have to re-emulate the same file. And you can set the number of hashes that are locally cached versus the ones you go out to the Threat Cloud to collect. So here's just a screenshot of and we have on the left, the default, and on the right are all of them configured. So there are a number of files you can emulate, not all of them by default. So you want to turn all those on that are relevant to your use case. Threat extraction is the next topic there. And again, you can configure the file types that you want to inspect. 25 of them are automatically included, although there are 49 that we can inspect. Here's that same visual of the default versus all of them configured. Also, the SK106123 provides a full list of threat emulation file types. So now we're going to build the rule base for our threat prevention. In Smart Console, we're going to go to the security policy, and then under threat prevention, go to custom policy. Here we see where you can create a rule base. Normally, a lot of people just leave one in here with an any source and destination, protected scope, and the optimized policy. We're going to show you how you can configure a more granular rule base. So moving on, one note here is the source destination columns are hidden by default. If you want to see those and configure those, you're going to have to right click on the top bar and add them in for you. Also yes.
Oh, sorry. If I could just throw it so when we're kind of saying about building that custom rule base here, to what Mark alluded to in the beginning, this is where you need to understand the traffic passing through the gateway, whether that's east-west, land-to-land traffic, or north-south going out to the internet, and understanding sort of how that fits into the potential to write different threat prevention rules. So, for example, if you're doing things like emulation, you probably don't want to be doing emulation on east-west traffic. Because if you just think about the potential impact of just you're technically moving files, you're moving data across the network. And that if you're doing that through the firewall in a kind of default threat rule where it's an any, then an aggressive prevention policy is going to be inspecting all of that traffic. So this is where you could get much more strategic, where Mark's showing that the source and destination are hidden, that you could write very specific rules that either include or exclude east-west traffic or traffic from certain networks from the sort of hardcore turn it up to 11 policy that we're about to create, to be a little bit more strategic about where the traffic's being inspected, so that we're not just slamming everything through every threat engine. Some of this might be traffic that you really want to do that deep inspection on if it's just coming from or going out to the internet.
You know, also another note is this is one of the key differences between the autonomous and the custom. We can, on the one gateway, have different profiles selected for different traffic flows. If you use an autonomous, it's one per gateway. So protected scope is a little bit different than what we do in firewall rules. The protected scope is going to inspect all traffic, whether the source opened that connection or not. So, and we can use a bunch of different objects for protected scope. We can use network objects, dynamic objects, domain objects, groups, updatables, zones, data centers, and roles for inspection. So an important point in this custom profile is that we use some of the automatically generated protected scopes, that being the external, the DMZ, and internal. So to configure those, you need to go on the gateways properties and go into, make sure each interface is properly defined in the typology, so that when we apply these, that they're applied properly to the right scopes. After we've done that, we want to go in and we want to create the profile we're going to use. That is in Smart Console under security policies and threat prevention and profiles. If you're creating a new one, the recommendation is to clone one of the built-in ones. We started from the strict and cloned that to make our deep inspection protocol or profile. So on the left, we have the strict default settings, and on the right, we have the maximum settings that we're outlining here. This in the general profile, this controls the activation of protections. You can set this based on the performance of the IPS, also the severity of the attack, and then on activation mode, you can set them to either prevent or detect on the confidence of that signature. In the antivirus setting, we see this protected scope is one of the first things we see there. By default, everything's going to be applied to external or DMZ, which for deep scanning is probably the right choice. You also can do all traffic going in and out. So by default, the protocol that's inspected is only web. If FTP and SMB traffic is in this, you certainly want to enable those as well. In the file types, we can do all of them. And again, we can enable deep scanning, which is different than just the reputation lookup. And we can also go in there individually based on family types, make a decision individually on them, how we deal with those. Also at the bottom, if scanning of archives is not on by default, it is performance impacting, you can enable that. And there are some additional settings on archive scans. So if you set the archive scans, you want to make sure that there's an amount of time that we're going to continue it without, and after that, no longer run it, so it doesn't run too long. And we can either, at the end of that, if it hasn't finished, we can either block or allow that type of archive. Here are a sample of the antivirus types that we support. There is quite a few of those. And each of those, you can see there are different default behaviors. Some are inspect, some are drop, and some are bypass. There is also a deep inspection that we're going to talk about next. So what is the deep inspection? It is going to actually scan the files with the engine on the local as versus just checking the reputation of these. Should you enable them all? You certainly can. And there are a bunch of ones that you probably want to, like unknown, HTML, XML, JavaScript, text, PHP. All these are definitely vectors where attackers can use these to send in commands.
And I think sort of the like hidden feature here that, and I'll admit, like I probably should have known this before going through all of this content, was, you know, the fact that you can go on a per file type basis and set your policy on antivirus to just drop this file type. So again, kind of back to Mark's point at the top of the call of knowing your environment, knowing what you want to let in, and, you know, probably more importantly, the things you don't want to let in. You know, so if you know there are file types you don't want users downloading, you don't want those file types traversing your network or traversing the gateway, in part of this profile, you can just start explicitly setting these file types to drop. So again, this may not be a deeper process in the threat prevention conversation, but just so much as, you know, why even let this stuff in? And why even bother scanning it if you know that it's junk you don't want? So if you're going to get deep and go granular in these policies, you can also get very strategic about just excluding whole file types in the first place.
Yeah, exactly. And that's what we're showing here. The box on the right with the different file types, these are ones we recommend that you definitely do some sort of inspection on, because all of them are highly likely that they potentially could be vectors for malware. And again, on each of these file types, we can do a drop, we can do a bypass, we can do an inspect, or we can do a deep scan where it scans it every time. Moving on to the threat emulation. Again, we can see the protected scope by default is the external and DMZ, where it's going to be applied. Protocols by default is just web. We can enable FTP and SMB, also mail. Since we set the global settings, our file types are already set to 88, which is the maximum. We can also do it individually by family here as well. Again, we can now also block archives that contain a certain type of file type here in this next config. So if we hit that config, we get a list, drop-down list with just about the same number of file types we had for antivirus, and you can go ahead and select those as blocking archives that contain these file types. So threat emulation does use different environments to do its work. We can set that based on the gateway setting, or we can override this here in the profile. We can use the checkpoint recommended, and I'll show you what that means in a minute. Or we can go down and individually check which stacks we do the emulation from. So the checkpoint recommended environment is Windows 7, 10, and then Adobe, Office files, and Java. We also support XP and Windows 8 as a legacy. Threat emulation. On the Advanced tab, we find the maximum protection versus rapid delivery, which is by default on all the custom is rapid delivery. And again, if we look back to autonomous prevention, the only one that does the maximum prevention is the strict. And what's the difference there? So the difference is rapid delivery mode is really designed to work with threat extraction because it is going to send the original file to the user, even if the emulation then turns out to be malicious. So if you're not running extraction, you probably want to think about turning on maximum prevention so that malicious files can't seep in, or make sure you're running extraction and emulation if you want to use rapid delivery mode. This is a little known feature of threat emulation. It is the ability to scan password protected files and emulate them. This is not included in the GUI. You need to go on to the command line of the gateways to enable it. There's also commands to show what the status of these are. It's very easy to turn on. You can also choose whether to fail open or fail closed in this. For our settings, we probably want to fail closed. Here's an example from my lab where I enabled it, and I also enabled it to fail closed, then show the status of how we were going to do it. This is also a feature that's included in Harmony Collab, where we can scan files in email that are password protected. And what it does is it does a guessing to see if we can get in there with well-known passwords or password lists from the internet. You can also use your own custom password list, where you create the password list and put that in a configuration file in the gateway and enable that. If internally you had a list of passwords you would use for files and you wanted to scan them, you could do this. Or if you had a good password list that you found that you wanted to use. So getting on to extraction, this is going to be sanitizing the files. There is some configuration we can do here. We can configure what parts of the malicious files get sanitized. We can also check what types we are going to do. Since we, in the general settings, turn them all on, there it is set to 49. 25 are set in the default policy. Here's a blow up of the extraction files that are set by default versus all of them. Here are the elements that you can control with the extraction config part. So all the really dangerous stuff are all in there by default. There's some others that you can turn on, but really are very low threat. Also, part of the advanced configuration for threat extraction is how we handle corrupt files or encrypted files. By default, these are allowed, even in strict. So we do recommend blocking both corrupted files and encrypted files if they can't be inspected or can't be sanitized. Dan, did you want to talk about the malware trap settings?
Sure. And Andrew, I saw your question. We'll address that one. We'll flip back to that one after this slide quick. So the malware DNS trap is something that's been around for a while, but whenever I've often talked to a lot of customers who don't understand what this does. Honestly, I don't know that it's documented very well on the checkpoint side. But basically, there are two places that this can be configured. We can configure it right in the threat prevention profile itself, which is how we see it on the left. But then you can also override some of the threat profile settings on a per gateway basis. So what this feature does really is it's part of anti-bot and antivirus, looking at those malicious post-infection CNC type DNS queries that the gateway looks at. And you may have seen in your own life in using these blades that a lot of times when you're just looking at your logs or in Smart Event, all the traffic, it just shows like it's all coming from the DNS server. So, you can say that's great. I know there are clients on the network making malicious DNS requests, but since the DNS server is forwarding those requests to the internet, I don't actually know what client made the request. I just see in my firewall logs, it's all coming from the DNS server. So one option is you've got to dig through your DNS logs, and that can be really ugly, really tricky. on a network with a high volume of DNS traffic. The other way is to leverage this feature. So if you just turn it on in the profile, we want to specify internal DNS servers in the profile. These would be servers that you are using that are internal to your network, that are forwarding DNS requests for the internet, or forwarding DNS requests out to the internet for lookups that don't exist on the server. So we set those up. If you leave it just default with it checked and no IP set, the default is 62.0.58.94. That is just a public address in Checkpoint's IP space. You can always change this to something else. You would want to set this to an IP address that is ideally an RFC 1918, not publicly routable, that you have control of in your network that is not used. Because basically, and you can next slide here, Mark. So what we're going to do is substitute, the gateway will respond to the DNS query that is malicious with this IP address that we specify here. So you can see this is pretty much the typical log example that you get when you say, great, I've got all these DNS reputations, but the source is my DNS server, so I really don't know who looked it up. The other thing that can cause confusion is you'll notice too, probably, that the action on these is just detect. And so you may say, hey, wait a minute, I thought we were doing prevent. So click for me, Mark. If we search our logs for that malware or that DNS trap IP, in my case, it was 192.168.200.200. If I look for this, I kind of see the other part of the story, in that we'll see that there's these events, trap events, correlate to the same protections that we're seeing in the list above. The only difference is we're actually seeing the source. These are the source IPs that made the malicious queries in the first place, kind of helping us tie that threat hunting piece all the way back to what made the request. And if we just expand these out to these other two screenshots, we look in the log details. I'm sorry if this is an eye chart, but we can see the original on the left, the detects, is the event of the DNS query being made to the DNS server. The prevent is the substitution of that DNS response with the trap IP, and then where we can actually see where that source IP is revealed. So this is a really great way to kind of get around some of the trappings of just, using internal DNS servers, proxying internet queries out, and how to get to the root cause of what's asking for those events. Andrew asked the question, does threat extraction support the same number of file types as emulation? And no. So looking at extraction, there are about 49 file types that extraction can do, and there are 89 file types presently that emulation can do. So the reason for that being that, some of these file types, like executables and things that we can run in the sandbox and emulate, we can't necessarily, don't have the ability to manipulate to extract threats out of. So if you've got a bad EXE, if you've got a bad, MP3, we can't really use extraction to make a facsimile of that. We can just emulate it and know that it's bad. So that's why there's not a one-to-one of file types between the two.
And we did include both SKs for emulation and extraction that detail exactly what file types both engines support at the end here.
Yep. So that's a little bit about the malware DNS trap. There's really no harm in turning that on. So honestly, like if you're using the Antibot Blade, that one's not really going to create any overhead. It's really only going to enrich the details of your logs and make your own investigations a lot easier. So I would say check that out. See how you have it set up. You could have each gateway send a different trap IP if for some reason it mattered kind of where the traffic originated from. You could make life easy and just use all the same IP. But that one is probably of the lowest hanging fruit of features I would encourage everyone to look at, kind of regardless of how deep you want to go turning your threat profiles up.
And if you made it this far, we have a little bonus for you. This is a brand new protection that just got backported from R8020 to JFH 70 for R8110, R8120. It uses IP port indicators to detect notorious botnets such as Emotet, Dridex, and Qubit. You enable this by going on the gateway and changing the IP port config.conf, changing the false to true, and installing policy. We do have the link for the SK below the documents that does have the wrong file conf in the document currently, but it's very easy to enable and a new protection that they just rolled out. So here's the work or the documentation for all this. We have links to the guide and all the details on the threat prevention. Also included a few links for the autonomous threat prevention. So in summarizing, there's a bunch of configurations. We only touched on 3 of the blades today that you can manually config to a maximum prevention setting. It's definitely worth looking at some of these. They definitely can add to your security posture. Also, I wanted a quick shout out. If anybody's interested in joining us for the PA user group, we're holding it at Trogs Brewing in Hershey, September 18th. We're going to be discussing things like this and hopefully talking to other customers and Checkpoint people and spreading the knowledge around. Thank you.
So there was another follow-up question here. Are there risks for running threat emulation as opposed to threat extraction? Or is it more about the choice of end user experience in receiving the file immediately as opposed to a few seconds later? I think that's a great question. I would say both both have their place. In that, depending on depending on kind of what the source of the traffic is coming from. If it's a user actually, interacting, pulling down PDFs, pulling down Word documents, I think to Mark's point that when we peel back the rapid delivery versus the maximum security, that probably the best user experience, if there's a concern about that, is leveraging the extraction for while the emulation is happening. So some of this, it might just be that the user experience is a faster delivery of the file, so they don't want to just sit there while it's being emulated. I think the upside to making sure you have emulation on or using the emulation component is that, there is sort of a whole workflow that threat emulation will go through. And ultimately, detonating the file in the sandbox is sort of like the last step. And there was the setting in there about the number of hashes that the gateway will cache. So, with emulation, the first thing we're going to check is, has this gateway seen the file before? And if the gateway already knows that hash and knows the verdict on the hash, we're not going to go any further than that. And we're just going to deliver the file quickly. So if everyone is going to the same website on a Monday morning to get a file, the quickest way, emulation will get that very quickly. So then the next phases would be, okay, if the gateway doesn't know about it, what does ThreatCloud know about it? And ThreatCloud, has billions and billions of hits and indicators generated every day. So chances are likely that possibly someone else on the internet has already seen this file, and we can just do a ThreatCloud query on the hash and give a verdict that way. Again, that's still the fastest way, or probably the second fastest way. Then, of course, if the gateway doesn't know about it, if ThreatCloud doesn't know about it, a quick verdict can't be reached, then it's going to have to go into full sandbox. So once a file potentially has got to hit the full sandbox part, that's probably where there might be faster, better user experience in delivering through extraction, as opposed to just doing emulation.
Yeah, I would add they really are complementary to a certain degree. And to get the best security, you want both. The file types don't match 100%, so there is some overlap there. And the ability to deliver rapidly a safe document while still doing the full analysis makes a lot of sense to me.
And I think cheap plug there too, in that, you know, these components exist beyond just the network, either in Harmony Endpoint or in Harmony Browse. So, you know, I think another important thing to think about is if you're really concerned about locking down on the threat prevention and threat security and what users are doing and what they're getting off the internet, if they're allowed to take their devices off-prem, if you don't do full tunnel VPN back to your data center when they're outside the office, then having something like Harmony Browse could be a very powerful way so that users are literally carrying these protections around with them, both on-prem and off-prem. So there are a lot of ways that, you know, these engines live that kind of give you that comprehensive coverage just outside of just the firewall.
Yeah, absolutely. The power of a security platform that shares those engines across all the different methods that we deploy them. Absolutely.
I'll mark that one answered. Do we have any other questions?
I think you covered it, Dan. Please, anybody jump in if you have any, type it into the Q&A. We'll get to those here, but we'll start wrapping it up since we're over. Thank you, Mark and Dan. Great information. For people that are still on here, as you can see, there's the default settings and there's so much more you can tweak. Obviously, it's a performance for protection conversation, right, Mark and Dan? So
Absolutely.
yeah, so talk to your local account team, reach out to us if you need any additional information. And as always, you know, if you have ideas of what you'd like to see here, please let me know. Drop me a note. If you want to go deeper in this subject, we can definitely revisit it. So just let me know what you'd like to see on these sessions. But thanks again, guys. Great information. We'll send a follow-up email with the reference content, those links Mark showed you, and the recording link. Our next webinar will be in 2 weeks. You'll see the invitation for that soon. So thanks for joining, and we'll see you here next time. Enjoy your day. Thanks, everybody. Bye, Mark. Bye, Dan.
Bye, Rob.
Bye, Dan.